In this lesson, we're going to talk about ratios. We are going to look at part-to-part, part-to-whole ratios, and then solve for a ratio problem. So a ratio is a relationship between two quantities. It can be written as A to B using the colon, A divided by B, or by the phrase A to B. This way is how you're going to see me write it, with the fraction bar going horizontally instead of on a slash. Per is another word that implies a ratio, as in miles per hour, how much something costs, price per item, grade per class. This can be part to whole or part to part. It looks like a fraction, only in part to whole, but it's not always going to be a fraction with part to part. If you think about fractions that you learned when you were in lower school or even in 6th grade, the ever popular pizza, if this was our pizza, we had 4 slices and we ate one, it was a 1/4 because it was 1 part out of 4, which was the whole number of slices that we had. The two problems that are up at the top, we're going to look at these at the end of the video as well. There are 21 people in the classroom. There are 2 girls for every 3 people in the classroom. How many girls are there? How many boys? So when you're looking at a problem like this, it helps if you either do some color coding or do a little bit of labeling. So you have 21 people in the classroom. There are 2 girls, and then this keyword 4 sets up your proportion. For every 3 people, how many girls are there? And then how many boys are there? So we'll take a look at this a little bit further down the road as well. There are 20 people in the classroom. There are 2 girls for every 3 boys. I should say boys. 4. Again, that's breaking up the fraction. So you have 2 girls and 3 boys. How many girls are there? How many boys are there? We'll set these up a little bit later. Part to whole relationships. There are men and women at a meeting. If the ratio of women to people in a room is 3 to 5, and there are 40 people in the room, how many women are in the room? So the reason this is part to whole is because the question has to do with women to people. Women is the part and people are the whole. Part to whole. 3 to 5 is 3 women to 5 people, or 3 fraction bar 5 is 3 women to 5 people. This can be thought of as a fraction because it is a part to whole, like the pizza. It's a part to whole relationship. Now, taking a look at this chart, you have, again, part to whole. So you have women, people, and then there are men also at the meeting. So if you have 3 women and then you have 5 people, how many would be men? Well, simply 5 minus 3 is 2. 6 women, 10 people, 10 minus 6 is 4. 9 women, 15 people, 15 minus 9 is 6. 12 women, 20 people, how many men? And that would be 8. Go ahead and finish off the table, and perhaps you might see a relationship that would make it a little bit of a shortcut for you as you're completing this table. Let's fill this in. We have 10 men, 12, 14, and 16. I'm not sure how many of you did the subtracting, or if you noticed that it was a +2 relationship in the pattern and you just figured it out this way. Make sure you have this chart completed in your notes as well. Now, this is a part-to-part relationship. There are men and women in a meeting, one part and the other part. If the ratio of women to men in the room is 3 to 5, and there are 40 people in the room, how many women are in the room. So looking at your chart, 2 is the key. So you have women, 2 men. And if that ratio is 3 to 5, and there are, so this is women and men, but we have 40 people, how do you figure out how many women are in the room? Well, we have, in the chart, we have women to men, which we know we must have 8 people. If we have 6 women and 10 men, we have 16 people. And if we have 9 women and 15 men, we have 24 people. And maybe you've noticed the pattern here as a +8. So how would we figure out how many women are in the room if we have 40 people? Let's go ahead and complete this chart up here. We started some of it. So we had 16, 24, 32, and 40. You notice by extending the chart, you can see that there are 15 women when there are 40 people in the room. But let's take a look at it mathematically. So I wrote down 3 with the little w to show that's 3 women for every 5 men, and then there's 8 people. That's the 8p. So we know that there are 40 people. And we've got to set up a ratio where we have people on the bottom. It's like we need a common label. So we know that there are 8 total people in this ratio, and we're looking at women. So if we have a 3 to 5 ratio, that's 8 people. How many are women? We have 3 women, and we need to make it the same. So just taking a look at equal fractions, 8 times 5 will get you to 40. Therefore, 3 times 5 will get you to 15, which is what we had up in the chart. The equal ratios that we're doing down here is just going to be the easiest way, because sometimes we aren't going to have the time nor the space to do a chart like this one up here. So let's take a look at the first statement. There are 21 people in the classroom. So I'm just going to write this down, 21 with my P for people. There are 2 girls for every 3 people. How many girls are there? How many boys are there? Well, I noticed that I already have my P's down here, so I can do 21P, and then I can figure out how many girls there are, because 3 times 7 gets me to 21. Therefore, 2 times 7 would get me to 14. So there are 14 girls. And then how many boys would there be? Be 21 minus 14, which would give you 7 boys. The problem right here, 20 people in the classroom, 2 girls for every 3 boys in the classroom. How many girls are there? How many boys? I'd like you to do this question. And then lastly, these 3 questions down at the bottom, you're also going to answer those 3 questions. I'll have these 4 questions on a Google Doc emailed to you on the website.